Section 5.2, simple interest. So the goal here, be able to use simple interest to solve problems. And overall, when money is borrowed or invested, there is often interest involved. As I alluded to in 5.1, interest is a big part of this chapter. So there's going to be interest involved. Borrowers have to pay it. Investments will earn it. And the most basic way to calculate the interest is to use simple interest. And simple interest, the defining characteristic, it's interest that is only paid on the principal. You don't pay it on the interest that you've already accumulated, only on the principal, the original starting amount. So how does it work? Well, let's consider a situation where $100 is invested at 10% simple interest for 3 years. And this is going to look real similar to what I did for linear back in chapter 4, but I want you to see where all this stuff comes from. Our goal is to kind of get a sense of why the formula does what it does. So the future value of this account, the amount at the end of year 1, so to speak, will be equal to the $100 that we started with, and then plus the 10% of that $100. Now that's the interest we earned, the simple interest. If I factor 100 out of there, I get 1 plus 0.10 in the parentheses. And when you work that out, you get $110. So your 100 grew to 110. At the end of year 2, I'm going to abbreviate this as FV now. We'll see that as a common thing. We have the $100 that we started with. We have the 10% interest that I earned in the first year based on simple interest, year 1. And then I have the 10% interest that I earned during year 2 based on simple interest, which we're only applying that percent to the original amount to calculate our interest. So this will end up being 100, and then we're going to have 1 plus 0.10 plus the second one from the second year. And I can really write this as just 100, and then 1 plus, you got two things that are the same, so we could do 2 times 0.10. It'd be this, equivalent mathematical way to approach it. And we end up here with just $120. So I've earned another $10 in simple interest. So year 3, the future value, we're going to have the 100 that we started with. We're going to have the 10% of that 100 that we gained in simple interest in year 1. We'll have the 10% of that 100 that we gained in simple interest in year 2, and we're going to have the 10% in simple interest that we earned in year 3. And now what we're going to get out of this is something where you got the 100 times 1 plus 3 times 0.10, and that'll end up being $130. So the first thing I want you to pay attention to is the fact that the number here in front of the interest part, the 10% or the 0.10, matches up with the year. Same thing here with the year 3, we got 3 times that amount. So that's going to be a common thing with the simple interest. So you're going to see that in the general formula, there's going to be a place where you're multiplying the years by your rate. And then the second thing, notice that we went from 110 to 120 to 130. We grew by a constant amount each year. So if I did this as just a general formula, year t, we could have the 100 times 1 plus the 0.10 times t. And if you graph this in Desmos, what you're going to get, let me go ahead and just jump over here real quick. You're going to get this line. And notice, like, you start at 0, time $100, then you move up to, oops, if this thing will move for me. Guess it won't. Guess I'll do this way. Oh, there we are. So at 1 year in, we were at 110. 2 years in, we're at 120, 3 years in, 130, and you keep going. 4 years, 140, etc. And you're growing by a constant $10 every year, and that becomes your slope of this linear-based model for simple interest. So simple interest is a linear growth, and that's because it's only getting paid on the principal, so you're just going to have the same amount being changed, every year. The formula for this, the general formula, you have F or FV, depending on where you're looking, is equal to P times the quantity 1 plus RT. So the P, defined as present value, you can think of this as principal or your initial amount. Whatever's going into the account to start out, or how much you borrowed to start out. Then the R is an annual percentage rate. So this is a yearly rate stated as the APR, or they'll just say earns this percent. If they don't tell you that it earns it at a certain time, you're going to assume it's a yearly rate. And then T is going to be the number of years. And because the rate is always going to be a yearly rate, if they gave you months for time, you need to convert that over to years by dividing by 12, because there's 12 months in a year. So keep that in mind. There's going to be problems where they're going to give you months, and you need to convert it to years to get the right answer. So another thing that doesn't show up in here but does show up in the problems, the total interest paid, I, can be found by subtracting the present value from the future value. If you know what you got in the future, you know what you started with, you subtract the future value minus the present value, and you will get the interest that you earned. Everything that's different between the two is because you earned interest or paid interest. So in this example here, it's going to be something that is a really important skill for you to have, identifying the different variables, because the formula, whenever you see simple interest being mentioned, you're just going to use this formula. But you got to know what the F is, what the P is, what the R is, what the T is, if it's being given. You got to identify that stuff. It's really important. So this first problem deals with that, and I want you to go ahead and read through that and try it. Let me pause. Okay, so we are looking for P, the principal or present value, FV, the future value, I, the interest, R, the rate as a decimal, T, the time in years. So Alexi borrowed $5,000 at 4% simple interest for 36 months. She now owes $5,600. Well, borrowed, past tense, or the original amount was $5,000, so that's the P. 4%, that's going to be your rate all day long, so we got to convert to a decimal. 36 months, I would normally like to say that's the time, but time is going to be in years. So we need to take 36 divided by 12 and get 3 for years. And she now owes $5,600. So that's going to be a future value. Anything that's further along than what the starting amount is going to be the future value. So filling these blanks in, we will get $5,000 for the present value, what the starting amount was, $5,600 for the future value after 36 months or 3 years. The interest rate, we've got to do a little subtraction here. We've got to do the future value minus the present value. That's what you'll always do to get your interest if they just give you numbers for those values. And when you work that out, you get $600 or $600 for the interest. The rate converted to a decimal, 0.04, and the time converted to years was 3. So, that's basically, what you're going to be doing in those types of problems. Not a lot of math involved, but you do need to pick the things out of the statement properly and be able to identify them. So many problems will give you some of the variable values, and then you have to solve for that unknown value using the formula. So let's go ahead and take a look at another example here. So Tomas has $1,500, but he needs $2,000. He found a savings account that will pay him 4% simple interest. How long will he have to leave the money in the account to reach his goal? So first thing here, as soon as you see the word simple with interest, you can write down this formula, because that's the key word that you're using. This formula is simple interest, or key phrase. And let's see, how long will he have to leave it in there? So that's going to be the T. We need to find T. So I'm hoping we got the other things in there. Has $1,500. That would be the present value, starting amount. So P is 1,500. Needs 2,000. Well, that's what needs in the future. The future value will be 2,000. And R, 4%, so 0.04. So you're just going to take these pieces of information, plug it in, and solve for the unknown piece. So if we divide by 1,500 on both sides, getting that T alone, I will get 4 over 3 after I reduce. And this will be equal to 1 plus 0.04 times T. And then I'm going to subtract 1 from both sides. So you get 4/3 minus 1 equals this 0.04 T up here. And we are going to get 1/3 on the left side after we simplify equals 0.04 times T. And then 1/3 divided by 0.04 would equal T. Divide what's being multiplied to get to the answer. And when you work that out, you will get that T is equal to approximately this 8.25 years. So Tomas may want to think about picking up a second job if he needs that money quickly. But at any rate, if you just plug in what you know and then use algebra to solve for what's missing, you will be well on your way to being skilled in pretty much all these problems. So we're going to see this showing up as a theme for a lot of these examples. And don't think I got enough time really to go through the next one. So we'll pick up example 3 in part 2.